I'm part of Compose. I'm CDO there. Fancy title for somebody who basically is like a software engineer that's bashing code with Rami. But yeah, so effectively at Compose, we're a team that tries to bring all your communications into the same platform. So what we want to do is effectively, if you talk to people on WhatsApp, on Slack, on Telegram, coming up soon, like we have Twitter, and even in the pipes, we have like email. We really want to bring all these different channels of communication under the same UI and the same interface so that you don't need to think, oh, where was this sent? How do I send it? How do I format it? It's all about just effective communication. So better than words, I figure it's more explicit to actually show you the platform. So this is like our interface. As you can see, you have like the labels at the top. You have, by the way, do you see the Zoom thing at the top, or like is it hiding? I'm not too sure. I'll just move it. Yeah.
Okay. No, it's good. It's good.
Oh, sorry, because there's an overlay, so I wasn't too sure. But yeah, like at the top you have like your filters, and you have like the chats that you basically have. And the whole idea is that it's currently I have my Slack that's connected. I have my I have my WhatsApp that's connected. I could connect my Telegram, but I don't really use it. And Gmail is coming soon. And so the logic is that I can really access the information I want to access when I want to access it. So let's say I want to talk to Rami, I could be, well, actually like go on Spotlight search and go like Rami. I'm like, oh, hey Rami, when are we meeting? And so like I can directly send a message to Rami like quite seamlessly. And then I can be actually, I want to ping Danny as well. And so I'd be like, Danny, and he's actually not that responsive on WhatsApp. So I'll ping him on Slack and be like, yo, when is the meeting with Rami? And it's really about like making these things like as smooth as possible and as intuitive as possible. And it starts with like simple things like messaging, but as well things like starting a new thread. So like just like I want arrow up, pressed R, and then be like, well, this is a test, and then boom. And so it's really about like making these things like very simple and intuitive. And as you can see, well, ironically, most of the things that are important are my work. They have just like family. But you can have as many filters as you want and really create like a sense of actually I have my work things, I have my family, I have my friends, I have other. And I can obviously like archive things if like they're complete. So I can have, this is all the conversations that have been marked, but I only care about the things that are like prevalent. Either I need to do something with this or like it's like still like happening. So yeah, that's roughly how the platform works. There's many different features. I'm not going to dive in because that's not the purpose of the topic. But if you're actually interested, like just sign up and we'll probably give you access quite fast. So yeah, that's to introduce a bit the product. Now, regarding this presentation, what I really wanted to make it about is something called the super bridge. So obviously in our endeavor to bring all these different communication platforms under the same hood, you need to interact with different APIs. And that can get messy very, very fast because each company has its own implementation with different data models, with different like endpoints. And it's just effectively a nightmare to make a sense of all of this nonsense. And the idea behind the super bridge is exactly that, is that as far as the interface is concerned, there's only a single API and a single format of information. So in terms of display, it doesn't need to think, oh, this is coming from Slack, this is coming from WhatsApp, this is coming from Telegram. It doesn't matter. It's just, this is a chat. These are messages. I know I will have a chat will have a title. I know it will have a topic. I know it will have like participants, and like a message will have like timestamp, the sender, its content. And so in this endeavor, we had two things happened. The first one was effectively writing this abstraction layer. And to write an abstraction layer, like, by the way, like an API is basically like the interface for, because I'm not too sure who's attending. So yeah, like API is just a fancy word of like the communication between like a client, like a user, and the actual server. So, and the first topic of actually setting up this abstraction was actually understanding all the different platforms and what they were giving us and how do we translate them. And it could be something that's quite daunting, because like if you consider something as trivial as an ID, so like a message ID in Slack is a timestamp. In Telegram, it's an incremental number, and in WhatsApp, it's a random hexadecimal string. And so like each and every one of them had like different reasons to create an ID that's very different. And yet we need to make sense of all of these and like streamline them so that they're consumed in the same way as far as the front end is concerned. And if you see this discrepancy in something as trivial as a message ID, I invite you to like imagine how like replies or threads or forwarding or like media upload start to look like. Um, and so like the power of actually doing such an exercise of actually building an abstraction layer is that you end up figuring out the best pieces of each and every one of these and bring them together. And so this allows you to firstly create this separation of concerns. So like as far as the front end is concerned, like everything is streamlined, all the data comes in the same format, and you're golden. Second bit is that your data has a somewhat of a guarantee, because like now that you understand what everybody's giving you and what are the data that you are given, you can then like streamline it so that it fits what you need. And last but not least, by doing like this exercise of like understanding the bits and pieces and how they work, you can create a kind of common pool for all of them. So you can streamline what every implementation needs and what gives you back so that it fits in your entire infrastructure. And the power of all of these means that when you actually come around to add another integration, it becomes really, really fast. So for instance, now Rami is working on like Twitter, and he's been working on it for 2 days now, and he already has like a first implementation, and probably within the week we'll have like it going to beta and later in prod. So it's really about having something that abstracts away, gives you like a standardized layout that allows you to really deal with all this different information as fast as possible. I know it's a bit of a lot of information that I just like dumped. Is everybody fine, or should I continue? Well, I will take silence as yes. And the second aspect of like this whole exercise of doing this abstraction is that obviously this didn't happen from the beginning, because as a company, even like forget about the product, we've been pivoting a lot. And so like original technology shifted, how we were building it, what technology we're using, and the end product actually changed. So as far as Compose was concerned, we originally were a web-based solution, and now we're like a desktop-based. And what this means is that we had a certain amount of restrictions in terms of what we could use and how we could use it. And because we went to a desktop solution, all of these restrictions kind of like went away. And what this means towards like what we were actually building is that we built, if you want, like a kind of proof of concept or first version that was working quite well, that our users were interacting with and getting whatever experience they needed, but it wasn't necessarily as robust or as efficient as we wanted to. And if you want, we had this project in the back of our minds to actually migrate to like the super bridge. So which meant that we had to rewrite all our tech stack at least the back end of it, into like a new project that would have like a more streamlined and more uniform experience. And if you want, it's a bit this notion of technical debt, in the sense that we knew as we were going that we wanted to do this migration, but as the time went on, we also knew that we needed to deliver something to our users. We needed to, if you want, assert that we were onto something and that it was worth building. And so we kind of accumulated this debt, because as the project grew, that meant that more and more things needed to be like rewritten and upgraded and so on. And so effectively, we reached a point where we had something stable, and we decided to clear out all this like technical debt. By the way, for those of you who don't know what technical debt, there's like a brief explanation here, which is effectively that you have a bunch of work that has been done, or some work that hasn't been completed, or like partially completed, and that you know that you have to eventually come back to and create a better version. And the whole concept of technical debt is, I mean, a critical concept of it, sorry, is more understanding where do you stand towards this technical debt and why you've reached that technical debt. In our case, personally, we were like in the, what I'd like to believe, the better quadrant, which is when you deliberately and prudently do something. So it's, you know that you're going to have certain debt that's going to accumulate, but because you have some business restrictions and some delivery restrictions, you accept that debt and keep a tab on it, knowing that you'll come back to it and eventually pay it back. Obviously, the worst is like when you're inadvertent and reckless, meaning that you don't know that you're actually doing something wrong, and it's just like piling up because you don't have the information and you didn't even bother gathering this information. But the whole, like, if you want, what I really want people to take out of like this topic is that technical debt is really something that will accumulate irrespective of your circumstances. Like, whether you're aware of it or not, whether you're reckless or prudent, you will always accumulate technical debt to some extent. And it's always important to be aware of that debt and how it grows, because like any debt, it will accumulate interest, and the later you pay that interest, the worse it's going to be. And in our personal experience, we had like the super bridge entailed, I think, 6 weeks of no new releases, whereas we were on a weekly release, if not like two releases per week. And you can see that this directly impacted our users, because they felt they weren't as engaged as before. We weren't releasing new features. We weren't giving them more incentive to come back. And like, we basically saw our usage tank. So it's always important to keep in mind, what is this technical debt? How much does it entail? And even like write some features without delivering them ahead of time, so that you can have like these kind of bullets, so you can keep people engaged while you have this downtime. Yeah, that's about it. I wanted to make this presentation like quite short, just to give you like a big overview, so we can have more conversation now. So yeah, shoot.
Thanks for that, Karim. I can kick off. I just had a question about the technical debt. So I guess more around the specifics. So you knew that you were accruing technical debt. What steps did you take to make it easy to then, or easier to then resolve it in the future?
If you want, I have this habit that is, I mean, obviously depending on the circumstances, it's either good or bad, but I continuously look back at the code I've written and see how it can be written in a better way or a more extensible way. So I might not do the full solution, but I will always try to take as many steps as possible towards the right one. And in that sense, it's like almost preparing yourself towards that migration. So in the case of the super bridge, it was really about creating a similar logic where like the data models were roughly like drawn out, data was streamlined, there was like there were like parsers, albeit like in a different language, but there were still like parsers for like these conversions, and there was like as well like somewhat of an abstraction even before it went to the super bridge. And it's really the idea of considering where you want to reach and what you can do with the given amount of time. And it's often the case that you would do a bit of the feature ahead of the time and just like package it so that like you think about it being modular and extendable so that you can eventually add things to it. If you want, another example is like reactions. So recently we added reactions onto the platform, and the idea is that the tooltip element, which was like created at the time, when I wrote it with like reactions in, I wrote it with like edit in, I wrote it with delete in. So I almost created like a full featured component, or like something that's quite extendable without necessarily delivering all the features. So like I just flip them off so that then it's a lot easier when I come back in to like actually implement what I need to do. And so it's almost this logic of like minimizing that when you can, or paying it whenever. So like it's not necessarily getting the technical debt at zero, but really managing it so it doesn't accrue to like an insane amount.
So flattening the curve.
Yeah, exactly. Like it's again, like it's always hard because you have to know how much time to spend and like where to draw the line. And personally, it's something that I can like dive really deep in. Like, no, it needs to be like the right solution. It has to work properly and so on. But thankfully, I have like Danny and Rami who keep pestering. It's like, no, we need the features. Like the feature was supposed to be in like stage. Where is it? And like, fine, I'll rack something up. But yeah, it's really about like finding this balance.
Karim, I've got a question for you. I'm sorry, I need to drop off in 5 minutes. But I wonder, could you just talk a little bit more about the Superbridge technical architecture itself? Like, is it, you know, a set of classes with an inheritance layer? Is it microservices with kind of common APIs? Is the transformation by configuration or by code? I'd love to just
like I'll
get into a bit more detail there.
It's I think it's the easiest like way to think about it. So obviously there's a lot of code that's around it to make sure that all the communication happens. So like we have like methods to create like the WebSocket communications. We have WebSocket and like obviously like a consumer, which is like the main class. So something that acts like a read and write pump that will get all the information and then associate it with the right like client and call the right method. So it's something that effectively, like as you can see, it's like, oh, I want to connect, yeah, like call client connect, and the client will just get the correct client. And it's the same thing for all the different methods. In terms of how it looks like in terms of the actual implementation, so it's this mixture between like interface and abstract class, even though like Go doesn't really have this notion of abstract class, which is a bit of a shame, because I would love to have like just called super, but I kind of did something quite similar. So the idea is that you have like obviously like an interface which will define all the different like methods that a client should try to implement. So it creates like this full API, and then it's the responsibility of each and every implementation to actually do it. And obviously you can just send a not implemented and it will just like return an error, or like if it's something that doesn't affect anything, just return it. And so all of these have like their dedicated implementation. So we can see, for instance, something that could be, I think one of the most interesting ones is more like sending. So like every method effectively will have like its actual implementation, but as well like a super method that's defined in like what's called the abstract controller, what that every client, like dedicated client, effectively extends. And so we have like these super methods that will set up everything based on the information. So to give you an example, here we're sending a message. If you look at the super will, based on the basic information that we have in the payload, so like the chat ID, the thread ID, the type and content, will create a full-fledged message object. And then we'll do, if there's any necessary like parsing of serializing, getting certain files, getting like the response, so that it will really do all the necessary steps that are like generic for all of them, and simply call get the actual implementation. So then as far as like the client is concerned, it knows it has like a full-fledged message object with the compose format, and it will do the modification based on this. And so it has like its own custom, if you want, implementation for that method. And eventually, if all goes well, it will just like return it to say to the super controller to actually like put it in the database, send the response to the front end, and all is golden. And so the idea is really creating this kind of pattern for all of them. So like send is a bit overwhelming in terms of like what it does. So something more simple like archive is actually quite clean. So you can see that as far as the WhatsApp implementation is concerned, you call the dedicated methods for like archiving. So it's like, is it archived? Like, do you want to archive it? Yes, then call archive. You don't want to archive it, then call on archive. If there's an error, parse the error, return it. Otherwise, you're golden. And the super is where like the actual like additional logic happens. So it will get the chat, check if it's archived, check if it should like do a hard archive, and then eventually do the synchronization, update the database, and send the response. So it's really this logic of creating like an abstraction that is common to all of them. So like a super method, and then just the dedicated implementation that has the guaranteed object structure. And if you want, in terms of like the high level API, it's everything is detailed in like where is it, in the carrier. So you have everything that's quite streamlined in terms of like what it should do. So it's really about creating like the endpoints like very explicitly, so that any front end can call the method that it needs to based on this.
I can imagine, particularly with messaging, that you know these different functions and commands require some form of state, and I can imagine that varies quite dramatically between the different platforms, where some are a bit more stateless. You can maybe rely on a little bit of independence. Others probably are quite stateful, where there's like sessions that are maintaining additional data, and that's a difficult thing to abstract away.
That's the whole idea of like idiosyncrasies, and obviously like you have to deal with the idiosyncrasies as best as possible. And this is why like fundamentally each and every one of the clients have their dedicated, if you want, local cache, which is any additional information that it needs to operate properly. So like WhatsApp, for instance, has quite a weird way of dealing with syncing. And so you have like a custom cache method that has all these additional parameters for like the sync. But all the other methods are quite straightforward in terms of what they need and how they act and how they operate. Especially that the way the IO works is quite straightforward, as in you have like a guarantee that if you do a request, the response is on the same, like quite similar to a REST request. Whereas Telegram, for instance, is quite different, where most of the actual like methods are pending. So like you will have a first request, and then you have to listen on a different channel for the responses, and then you need to bind both of them together. And in this case, you have like something called like the pending upload to actually do the map between what is pending and what is being processed and so on.
And are those caches keyed on like a user or a message stream?
So each client is effectively its own like object. So like to answer your question, every connected account, because you can have multiple WhatsApps, multiple Telegram, multiple Slacks, will have its own like cache for its space. So again, like the idea is that some of them have a lot of like common information that is like replicated, others don't. So like again, like Slack has like the notion of a workspace, which like brings a new dynamic to it. So it's really about bridging all these things and making sure that like it's like.
And are those, is that state serialized somewhere and shared amongst different processes, or actually you're just storing that in memory, and if you lose the app, you can recreate the state if somebody reconnects?
The way the whole application is built is that everything is run on the client. So like on your machine, you have the Superbridge that's running. So as far as we're concerned, there's no server that's operating or anything. Like we don't want to deal with that nonsense. So like, and obviously this means that things like privacy or data privileges or things like that, it's none of our concerns because everything happens on your machine. So it's like removing that issue. And in terms of syncing, there's two things. One, fundamentally, you need to be connected to all these messengers to be able to interact with them. And this, like, if you want ephemeral state, is like resynced every time you reconnect to that specific platform. So if, for instance, you like, for instance, like the workspace, we're not saving the workspace anywhere, but every time you connect, we make sure that we pull the workspace and that you have the information about that workspace. So like all this kind of ephemeral information is like ephemeral. So there's no point in keeping it. Now, having said this, further down the line, we want to create a offline mode so that you can actually interact with your messages, albeit in a more limited way. You could still like schedule some messages, interact with your previous media, or like just look at historic things. And this is how like the actual database, like local database works, where a lot of this information that we know is more robust. So like the list of chats, the list of contacts, your messages, your files are always there because there's no point in re-downloading it and adding additional loads. So yeah, like it's kind of like there's two different categories of data. Like either it's ephemeral and we know we can always resync, or it's like quite like solid, and so we just like store it and reload it when necessary.
Cool. Thanks, Karim. That was helpful. Unfortunately, I need to go now. Thanks for the talk, though.
Any other questions?
Yeah, I've got a question about failures and retries. So if you fail to send a message to Slack or WhatsApp, do you retry how many times, and do you actually do that in code, or do you use some kind of service which does the retries?
So this question is like a multi-layered question because there's many different aspects. So first of all, we need to understand why the message wasn't sent, and by understanding why the message wasn't sent, we could then act on this. So if it's something that, for instance, like you don't have Wi-Fi, then we can definitely resend it later. And like it's more a question, not necessarily on a retry policy, but more, well, we don't have connection, we're gonna pipe this request and eventually send it once we know that the connection is established once again. Or it could be an error where like for some reason like the external server had an issue or on a communication level, or like I don't know, like some availability issue, and then we have like somewhat of a retry policy which is gonna try to send it like it's effectively something that's configured. I forgot what was the standard one, but I think it was something at a logarithmic, like exponential rate, sorry, that will try retries to a certain extent and then like notify the front end / the pipeline that it could not execute this request, so that the user is actually aware of this. And the final kind of error is that if there is invalid information. So in this case, there's no point in actually retrying it because you're trying to do some invalid action. So if you're trying to send an incorrect message, for instance, there's no point in retrying to send an invalid message. So we won't bother retrying it. We'll just notify the user. Having said this, most of these are actually caught from the front end's perspective, or like the bridge has like security mechanisms. So If you try to send an empty message, it will be like, well, it has no content. I won't even bother sending it because it has no content. So yeah, like it really depends on what's the kind of error, why it happened. And based on this, you then have a retry policy. In terms of whether we use a third-party retry, no, everything is like the super bridge will handle this pipeline of requests.
Okay, thanks. I've got another question about the messages themselves. Like when you send a message, do you actually store the content in your backend somewhere in the database? Do you delete it after it's sent?
We personally don't have any servers running for you. Like the only thing we have running is like an authentication server to prove that you have a Compose account, and that's it. So this is how we make sure that you actually are paying the subscription eventually, and that you have like the latest information and so on. As far as your messages are concerned, we're directly connected to that platform. And what this means is that if there's, for instance, like encryption, it goes through the encryption pipeline. If there's no encryption, well, there's no encryption. But nothing goes through our platform. The whole idea is that it really connects directly. And then in terms of storage, everything is stored locally. I mean, the logic is that, for instance, if you send, if like you receive a file, we're going to store this file on your machine so that when you resync, we don't need to re-download the file. Or if you want to view it or download it, it's already there, as opposed to rely on your connection to then get this information and back. So yeah, like in terms of data, we don't store anything personally, and the rest is just on your machine.
Okay, that makes sense. So basically the bridge that you were talking about, is that something you host on a server? Or
No. The bridge is packaged in the app. Like,
on the client?
Yeah. So if
Oh,
you like,
okay.
I can actually show you the activity monitor. Bridge. Yeah, there you go. Bridge server. That's the one. So like it's literally running on your machine.
Okay, cool. So are you thinking to kind of support multiple devices, and then I guess it would be the same idea. I was thinking about syncing all the messages, but I guess then you go to the provider and you know, like Slack or WhatsApp, and then you download all the messages from them.
Yeah, like the idea is that, like in terms of like your messages and so on, there's no point for us in storing them or using them. You can always like resync that information, and you'll get like technically even more robust, because that's another thing, is that fundamentally the message history in some cases can be edited. So like a message can be deleted, and if you weren't connected when this happened, we effectively have no way of knowing if that message was deleted or edited and so on. So like I even reckon it's even better to have like a syncing, like an initial syncing mechanism versus trying to coordinate multiple devices together. Like you have like a better guarantee. Having said this, we always like in the background like check whether the history is matching, and like do some tweaks to make sure that whatever information is displayed is the correct information. So if a message gets edited, you actually know that this message was edited or deleted, as opposed to having the incorrect value.
Yeah, plus, you know, GDPR and all that. Like you don't want to be storing
like,
people's,
I think very fast, and that's why we moved away from like a web solution, is that we were like, do we want to handle privacy policies and data privileges and so on? We're like, no. Like the strategy with like GDPR and like data privacy in general is that the less amount you actually store, the better off you are. And like eventually we do intend to have like some more interesting features that might require some storage on our platform, like things like creating a contact card. So assuming that you have somebody on WhatsApp, on Telegram, on Slack, on email, it's the same individual, and we can actually consolidate that information to create a unique user across all your platforms. And then you could supercharge things where you could say, well, I know I sent this file to that person, but I don't know if it was on Slack or on email. And we could show you all your media across all the different channels of communication. Or you want to talk to someone, you know the person, but you don't know where, like which conversation or which group. Again, you can tackle exactly where you want to talk to this person. And this kind of information, we might give the option to the user to like persist on our server. But again, most of the information, if it's not required in terms of like, if it's something that doesn't concern the platform itself, like as compose, we wouldn't store it because it doesn't bring us anything.
Okay, and the last question, I'm not sure if you mentioned that because I came kind of late. So you're using Go, and I assume the service that's running in the background, the bridge, that's written in Go, and then what do you use for the UI itself? Because you said it's not web-based solution, it's desktop-based.
So ironically, we're using Electron. So
Okay.
Electron is like if you want, a desktop wrapper, which creates somewhat of like a Chrome browser.
Yeah.
It's like dedicated for that solution. So the actual code is written in JavaScript. And so we could then like package it. And the advantage of using such technologies is that we're quite agnostic of like the operating system. So like Go has a very good like compiler to like create like a different binary for like different architectures. Same thing with Electron. So like you can package something for Windows, for Linux, for Mac quite easily instead of having to go above and beyond and write your like another application for these dedicated operating systems. If eventually we will do this in a unified way, maybe, because like I do know that like often native solutions offer you certain things that are optimized, and it could be something as trivial as managing lists, which is a nightmare when it comes to like web, especially if you're dealing with like virtualization or lazy loading and concepts like this. Well, thankfully, I think we have something that's working, but the logic is that usually native solutions have things out of the box. So like, for instance, if you're developing like in Swift for like a macOS app, you get to tap into their entire UI library, which is like quite powerful because it's designed to run on these machines. So you can definitely have like a boost in performance. But yeah, in terms of like what we actually use is Electron. So like Node.js app with like React style components and things like that. So quite standard in terms of like web dev. And the backend is written in Go, because like it's kind of like this good mixture between something that's like quite robust, quite fast, and quite easy to get a grip of. Like, I mean, I don't know how like in general it's easy, but like for me, I think I picked up Go in like less than a week. So
Okay, cool. Yeah, Go is really kind of easy to pick up. There's not that many things you need to learn. So yeah, it's good in that regard. We actually use Go as well in our project. Yeah, and if you're thinking about creating an app in the future, like a mobile app, I'm not sure if Electron supports that or not, but have you considered using, because you mentioned
there is
using.
And regarding this topic, it's really a question of knowing what are your resources, but even beyond this is knowing your target market. So there's no point in like, it's almost, if you know that the vast majority of your users are on iOS and you're just starting, I'd say don't go the React Native hybrid application. Just go on and build like an iOS app. Because again, in terms of like the look and feel, the actual output, I can almost guarantee you that you're gonna have something that's better. At least that's my opinion. So it's really this philosophy of knowing what is your plan and how are you gonna tackle it. And it goes back a bit as well into this like technical debt notion. So you don't be afraid to build something as a proof of concept and then like having to restart almost from scratch, in the sense that if you feel you're not so sure about your idea and you want to get something quick and dirty, it might make more sense to build it as a React Native app, get something out there, get a few like iteration cycles, and then be like, oh, actually now is when we look into like more native integrations and things like that. I mean, there's no absolute solution. It's really on a case by case. Like a whole other dimension is as well, like, do you need some device specific plugins? So if you're using the camera, if you're using the accelerometer, if you're accessing like certain key features like this, it might be a lot easier to just go with like a native app, because again, like all of these are, if you want, built in and designed in the language, so that it's a lot easier to actually build. Does it make sense?
Yeah, completely, and I agree. If you know, depends also on the app. What are you building? If you need things like accelerometer or, you know, camera and all that, and yeah, and you need performance as well, going native is probably the best decision. But if it's pretty simple UI and you just need, you know, the users to fill in a bunch of forms and just send a request to the backend and maybe display some things, then I would probably go the multi-platform way, something like Flutter maybe. I think it's got better performance than React Native, but probably without, there's probably some kind of, you know, bad things in Flutter as well as compared to a native app.
I mean, again, the idea is that you figure out what technology works best for you to get something out there, because especially when you're beginning, like, I'm assuming you don't have infinite resources, may it be monetary or like skill wise. I mean, personally, we're a team of 3 people, and it can get quite hectic, and often the way you compensate for this is literally spending more hours. But even with this, like there's only so many hours you're awake and able to actually work. So always, like, you need to consider like your users, what you're building, as well as your resources, because like it doesn't make sense for you to build the most optimized thing, but not reach that full project, and just fail, because obviously, like, and I think this is like one of the things that is annoying, but you have to accept, is that you're bound to rewrite things you previously built, because it will reach its maximum capacity. And we face this in many different instances. So for instance, I can tell you like the example of our like input box. Originally it was like a basic HTML input, then it became like a content editable like div, and then it became like a I think we used for a while like Quill editor, which is like a package. Then we shifted to Slate, and then like I hacked in like additional features into Slate, and now I'm considering rewriting it from scratch. So like you can see I'm dealing with the same thing and rebuilding it multiple times, but I had to do this because of the different like points in times and entries. So in our first version of the application, we like our users didn't care about like formatted text or like fancy implementation or like shortcuts and things like that. All they wanted to do is, can I send a message? Yes, no. And it's really about like having in mind what you're building and what are your iteration cycles. Like, don't wait until you have like the best fully fledged perfect solution, because like you can often die before reaching that point. It's really about like having these short iteration cycles and gradually but surely going towards like what you want to do. And again, this is where it's like you need to consider your resources, your deadlines, your users. I mean, again, there's no perfect solution. There's no perfect equation. It's like really a case by case. And it's really about considering all these things to make the better decision in that scenario.
Okay, yeah, thanks. That's really some good advice. And yeah, lean startup comes to mind as well. So yeah, thanks for that.
Pleasure.
Hi, I was just wondering what your situation is in regards. You said you work in JavaScript. we found personally that we work in JavaScript and we sort of met our limit with how much we could handle in terms of technical debt, problems, and we're spending a lot of time debugging. And we spent, I think, about 6 weeks converting to TypeScript. And it's been absolutely incredibly useful for us, really decreasing a huge upfront cost. Like I said, that's 6 weeks, but we found it really, really helpful now going forwards, decreasing the amount of debugging time, increasing the speed of development because, you know, there's less documentation to look up and less confusion with what you're working with. Is that something you work with? Have you considered it?
So that whole notion of like JavaScript, TypeScript, even I always forget the name. There's the way to actually add in JavaScript like certain typed modules and so on. Like effectively, JavaScript is this kind of black voodoo magic, and the reason why I have a weird relationship with JavaScript is I've been coding long enough JavaScript to kind of be used to all of its like quirks. But yeah, like definitely, if you want, the reason I love JavaScript is because it has almost zero limitations. Like there's no types, there's no guarantees, there's nothing. You can create really funky things. Like I remember writing something where there was like property defined as like getters that would do like some funky shit and like real-time dynamic loading to get the information from, like, it used to do something that was crazy in order to like memorize something while abstracting all this information. Like it was like hyper complex function that was just like this dot blah at the end. So like definitely JavaScript is like this weird thing that can go in many directions. And I think the reason why you feel moving to TypeScript is useful, and obviously if you can make the move, definitely go for it, is more regarding the quality of people that you end up working with and the general like guidelines. So, and I have like this massive contrast when I switch from Go to like JavaScript, because like Go is like very typed and has so many like protections. Like it will even complain if the name of the function is redundant. It will tell you, oh, your package name is like API and your function called is API call. It sounds like it stutters because it's like API call, rename to call. Like you're like, damn it, like let me name how I want to name things. But the idea is that obviously, like if you have something that's typed, you can have something that's more safe and more robust in terms of like the expected input and output. And like as you mentioned, the amount of documentation is often a lot less because like you actually have types and you don't need to explain what it takes and its format and so on, or like what is or the abilities that specific object has. But on the other side, you might have you introduce somewhat of a longer curve in terms of development, and I think it's quite similar to my relationship with tests, in the sense like it's something that you know is essential as the product grows, but you don't necessarily want to allocate time for it. So first of all, like kudos for you guys to actually migrating to like TypeScript. And yes, it is something we considered, but because we don't have the resources, it would take way too much time to actually do. And if you want, I think the common pitfall with these things is that for languages like JavaScript, it's quite popular, and so the actual faculty and understanding of like the talent you end up working with is going to be quite diverse in terms of like either they have no clue what they're doing or like they're pros at it. And it's like it's like this weird thing where it's good because you can get something that's up and running quite fast, but if it gets complicated, you need to make sure that what's around it is quite robust. So if you want the lesson, and I think I've kind of lost a bit the conversation because I'm formulating my statement, is that if you have something that doesn't have types and something that's quite rogue as JavaScript, it's highly important to actually document things and like write comments and have things that are quite explicit. So don't be afraid to have like many different functions that are quite explicit. Write a small snippet in terms of like what this does, what it takes, and what it is expecting. And if you kind of do these things, you're able to mitigate the downsides of JavaScript. If you're comfortable with TypeScript and like you're happy to use it, go for it. Like I'm not particular about it. I guess it's just I kind of like JavaScript for all its quirks and all its nonsense. I actually quite like it.
I think what you're saying in terms of the talent pool being very diverse is also like bang on the money, especially in terms of not just the talent you're working with, but also the amount of different developers. So obviously, if you've developed some JavaScript, you probably have a close relationship with exactly what's going on inside, whereas another developer might see it as a bit of a black box, and you can either delve into that code and start understanding how it works and what you need to pass it, and looking at the documentation that was given for it, or those types for a more typed language, especially for newer developers or people who haven't necessarily made the code that they're dealing with. It's a real crutch documentation type where they can really get some more insight into what's going on, how they need to be interacting with this work without understanding it deeply.
Oh yeah, and like it's even more interesting when you start hitting like packages and preferences and coding styles and things like that. And I mean, this is why, and the guys often complain about this, is that I'm quite strict in terms of these things, like in terms of how like the naming conventions of files, naming conventions of methods, like the structure of the code, like comments and things like that. I think it's very important to set like guidelines and rules so that it's uniform across your code. And sometimes like it's almost on the like OCD level, where it's like, no, your imports are in the wrong order, fix the order. Which again is quite intense, but the flip side.
Don't worry, we have a code package that is called import sort, which alphabetically orders all of our imports.
You see, mine is more semantic, so like it's trickier. But the logic is that you're able to actually find what you're looking for, and I think like as a broader thing, it's as well like, because we touch upon like talent, it's really about creating this environment that is somewhat restrictive, but enforces guidelines to make sure that everything is working nicely and everybody can reuse the code. Like it's ridiculous, but I remember like I worked for a while at Adobe, and it's like massive companies with like tens of thousands of like developers and engineers and so on. They didn't have a uniform coding style, like, you know, like a linter. They didn't have one that was shared across like projects, which is insane. I'm like, how the fuck do you go about like building such a massive company without like enforcing guidelines? I don't care what this guy says, just enforce it. Say from now on everybody follows these guidelines, end of discussion. But like ironically, that's a pitfall that some people like neglect, is like really create these guidelines in terms of like, what is the methodology of development, how do you go about like writing comments, how do you go about writing tests, how do you go about all these things to make sure that like your code is robust and actually understood by everyone who's working on it. And it's a hard thing, especially because like time is involved, and you often justify not doing it because you have a lack of time, but you often regret not having it when things go wrong. And it's again, it's like almost this pathological thing where, for instance, you don't write a test because you're like, yeah, I don't have time to write the fucking test. Like nobody cares about tests. It works. Let's move on. And then like a week later or 2 weeks later, there's a bug because like you've edited like some of the behavior for a specific case, and then other cases broke, and then you're like, oh man, I didn't catch this, how could I not? And then you write a patch for it. Whereas if you had like a test, then you would have caught it originally without having this whole cycle. And you have something quite similar with comments, where if you don't write comments, I would almost challenge you to reread like code you wrote like 6 months ago and be able to tell exactly what it does. And I do find myself sometimes saying like, what was that about exactly? So yeah, it's guidelines. Everybody hates them. Nobody wants to abide by them, but they will save your lives and when it matters.
Well, I mean, the people who don't hate them are the people who review code, right? But yeah, I think that's what we found with TypeScript as well. Like, it's an extra 10%, 15% when you're developing, but then when you've got a bug, you know, it's 5% the time to fix it, because, you know, most bugs don't happen because you've already caught them. But it's that give and take with all those, like you said, testing, documentation, comments. It's all that same give and take situation where you've got to make that, coming back to your technical debt quadrants, you've got to make those deliberate decisions. Am I going to write this comment? And I would probably argue that not writing those comments can be reckless at times, especially if you've got really dense, complex code. But it always pays off to, or almost always pays off to put that little bit of extra, you know, that 5-10% extra to document something a bit better, and pay it off when those 2 weeks are up and you've got an issue with it.
I found that especially when I have to, because working on different projects with different companies, if I ever have to hand over the work that I do, the time spent trying to explain everything I do because I didn't comment it or document it properly, I just get annoyed at myself. So yeah, especially with handovers as well as
I think the tricky part is that it often seems obvious because you do it. It's like, yeah. Like, obviously, this is how it works because, like, 1, 2, 3, 4, 5. But you forget that your entire reasoning is based on all the nonsense you've hit prior to this point. And even like I recently had this with like Rami when like he was doing something on the super bridge and there was this method called like message put. And he was like, yeah, obviously you call them the method called like messages put to like put a message in the database. And I was like, well, about that, it actually has certain side effects that do like this and that, and it shouldn't be used without knowledge of 1, 2, 3, 4, 5. And he was like, where's this written? I'm like, yes, about that. So yeah, like it's like I think you should always say to yourself that you're writing code not for yourself, but for whoever is gonna read it next. And like again, it's really about having things explicit, like and stick by like easy rules. Like for instance, don't have massive functions. Like a function that has more than 100 lines is like too big. Like don't like split it, have like a helper function that doesn't cost you anything, but it will like catch that specific case and it will give you context. Because like for instance, let's say in our case we need to parse messages, so you obviously have the root, but you also have like the content, because the content then goes to a text message, a contact card, a media file, a location, a whatever. And by simply just creating dedicated message for each of them and having like a switch, and then it expands. You then don't need to create a new block and write a comment. This method will actually parse a like media file because it's done. Like the method name is media file parser. Like doesn't need to be like something crazy. It's just like does what it says. Like again, it's like these common sense things. Like don't name a function A. Like so,
awesome. Well, thank you. I think we've run out of time, but thank you so much for doing this, Karim, for sharing your knowledge. It was really interesting, and thanks everyone else for joining as well. And yeah, I'll send out a link to Compose so people can try the product. I'm sure people are keen to try the product, especially after hearing the effort it's taken to build it.
And I'll probably like maybe like chuck in like the link to these things if like it's of interest for anyone, like might as well.
Yeah, awesome.
Cool.
Right,
Awesome.
thanks everyone.
Thank you.
Thank
Thank
you.
you.
Great.